We are recognizing means what? We are identifying that object. This is hexagonal bolt. This is circular bolt. Likewise. Now, feature. Let us talk about feature. Feature is mainly stored in this model base, and again it is freshly calculated for incoming object also. Now, feature is that attribute. Based on this feature, our recognition, describing, classifying, detection, all these processes are going on. This feature can be size, color, shape, mathematical parameter, statistical parameter. It depends on your strategy of object recognition. On which strategy, on what basis we are recognizing the object, on what basis we are recognizing the object. This strategy will decide what type of features are required. And then according to each of feature, various programs or algorithms has to be selected. Decomposition of shape, classification of color, calculation of size using geometrical operators, distance finding. These are various types of features which are available or which are utilized in object detection process. The features can be qualitative as well as quantitative. Many times we will say that particular thing, that is the texture is smooth, yes or no. Or many times functional description will be available, presence of threads, absence of threads, or presence of particular part or absence of particular part. Or you can have surface information, you can have various dimensions. So it can be mathematical, or it can be qualitative or quantitative. It can be number, or it can be yes no decision also. Now the feature detector is actually algorithm or program that is applied to the incoming image. These operators are transforms. These operators are transforms. Identify where are the features in the image. For example, color. So where is required color? That region of interest will be formed first. Already image is segmented. So in which area that required parameter is there or that feature is there. Based on these features, our guess, that is what hypothesis is formed. Now the features are always dependent on what type of recognition system you are doing. Similarly, how your database is organized or prepared, what you have considered when you form reference database or model database. Similar things will be applied at feature detector program. More the accuracy of these features, then less time will be required for guess formation, that is classification. And then recognition as well as verification will be very fast. In the diagram, whatever we have referred, if more matches are there, then naturally process will be delayed because each and every possibility is to be checked. Now hypothesizer, which forms the hypothesis, and that hypothesis is verified. Now hypothesis is the guess whatever we are forming. So based on these features, possible or possibilities will be generated. That is what called as hypothesis generation, or many times hypothesis formation. And checking the parameters or possibilities against model database is called as hypothesis verification. Result of this is recognition. Continuing to our same bolt example, that is nut bolt example, if this color is present, as a picture is extracted as this type of color, same color is there in model database, yes, this is what size detected. Same size is available in model database, yes, this is what shape is detected, hexagonal shape is detected, same type of shape is available in model database, then all these things are matched, hence this is hexagonal bolt of this size. This is how hypothesis is formed, verified, that is guess is given, guess is verified, and then whether it is checked whether guess is correct or not. This type of process is called as matching. In very simple words, this incoming image is matched with image of reference. Image of reference is stored in model database. It can be one or many. So all these reference images will be matched to this image, and whichever it is matching maximum, that will be recognition result. That's why whenever you are enrolling in fingerprint recognition, 3 samples are taken, or whenever you enroll, 2-3 samples of face are taken. Reason behind this, that is what your reference database. Whenever you stand for recognition, your image will be compared for all of these three, or any one which matches maximum, that will be declared as matched or recognized, or your face or fingerprint is recognized. Hypothesizer, actually it find out possibility, similarity, likelihood. So whatever detected feature is there, whether that feature is present in the scene, whether it is possibly matching to the reference image, so that guess can be formed. The verifier now verifies to all that selected guess candidates with model candidates, and then it provides correct evidence that how much percentage it is similar, how much it is match, so as we can say that it is correct object classified, detected, or recognized. Now this is what example we are matching two objects. So we will be comparing, this point is here, this point is here. It is similar to, let us say, matching a face. So whether hairstyle matches, whether forehead matches, whether eyes are matching. So every time we check each of locality, that is what each of feature. So now if I am having face as a image, then what are image features of face? That is the shape of eyes, shape of nose, shape of forehead, overall area of the face. So one to one these parameters are matched. This is how verification starts. So whether eyes are matching, yes or no, whether nose is matching, yes or no. Now all these points in a given image are located. That is nose at particular place, eyes at particular place. These are called as interest points. So interest points of input image and interest points of model image. Input image is called as scene and model image is called as stored image. Then in model images, we are having various images. So match 1, match 2. So first images is having 4 points, second image is having 2 points. So you declare for match 1. In database, even the object is one, we are having multiple images. So which image correctly matches? That is also very important. Now, hypothesis generation can be associative. It can group various features like shapes, arcs, lines, segment. It can define particular area. All these are called as local descriptors. So from this image, local properties of this image we are using. So this image is having a particular white background, but that cannot be used as the recognition part because there can be many white objects. So what we rely on that, the objects which are distinct, object which are giving identity, that we will be deciding. So this particular shape cannot be replicated or it is unique. So we decompose this shape. Decomposition means we find that how many arcs are there, how many lines are there, and this is what called as local descriptors. So in hypothesis generation, for grouping of the shapes or grouping of the information which is to be matched, we can use symmetry, similarity, proximity, that is closeness, opening and closing, crossing, smoothness, all these parameters we can find. We can work on orientation, that is direction, linearity, collinearity, parallelism, this line is parallel to this, proximity, this and this is close, convexity, that is how much shape. So various such parameters we can define so that our object recognition process will be speed up. It will not be mere computation of all mathematical features. There are logical features also. This all comes under shape description or shape recognition, where we decompose the shape. Maybe many of you work on CAD, so you know all these details, how we decompose the shape using these nodes. Now, in all this process, whatever we discuss, many complexity may arrive